Alright, continuing with the trig unit, we're going to kind of change pace though. We're going to go back to solving triangles, and if you remember, so far you have basic trig, sine, cos, and tan to solve triangles. We're going to introduce something new called the sine law. The sine law, this formula looks really complicated, but we will never use it in this form. First of all, this and this are the same, they're just flipped upside down. It doesn't matter which way you decide to start. If you want to start with sine A on top or A on top, it doesn't matter. Okay. The other thing that we'll never do is do an equation that has two equals in it. Okay, we're always going to just use two of these ratios. So we might use like those two, or maybe we'll use, those two. You'll see what I mean by that. Okay, when can we use the sine law? Well, first of all, if you have a right triangle, okay, you should be using trig. You should be using Pythagoras. Alright? Always if it's a right triangle. Sine law is when it's not a right triangle. Okay, and there's a few more conditions. First of all, we can use it when there are two sides and the angle opposite a known side. This is key. There has to be a side and the angle opposite. If you see here we have an angle and the side opposite, you have to have this to use sine law. Okay? The other way we can use sine law is if there's two angles and a side. Again, you have to have the angle with its opposite side. Okay? And then if you look at this one, question mark, here's our side, we don't have this angle. Except you actually do. Because in this case, you're given these two angles. You could find this one by going 180 minus the two angles. Okay? So again, then you would have the side and its opposite angle. Alright. So, as I said before, it doesn't matter which way you use these. It says here that if you're trying to find the length, it's better to have the lengths on top. If you're trying to find the angle, it's better to have the angle on top. Okay? The way I'm going to show you to do this, it won't matter which way you do them. Okay, so let's look at a question. Here's a triangle and it says determine the length of GH. So it's supposed to find this length here. Okay? And you can see it's not a right angle triangle, so you can't use trig. Okay? So I'm going to write the trig ratios that we had on the previous page. This was the formula. Alright, and the first thing you should notice, the problem is there's no ABCs. Okay, so that means we're not going to use this formula the way it's written. Instead of A, I'm going to use G. Instead of B, I'm going to use H. And instead of C, I'm going to use J. Again, it doesn't matter what the letters are. It doesn't matter the order you write them in. Okay, as long as you have an angle with its opposite side written as a ratio. Okay, now let's just check to see if we know what that means. Here is angle H. What is the side across from it? Little h. That's why we have it written like this. Okay, if we look at G, here's angle G. What side is across from it? Side G. Okay? So that's how we've set it up. Now let's fill in what we know. We know that angle G is 51 degrees. And we know side G is 7.8. You do not know angle H, and you do not know side H. You know angle J, and you don't know side J. Now, a couple of things to notice here. We're supposed to find GH, which actually is also side J. So, we need to use this ratio. Now the question is, which of these two ratios should you use? Well, obviously, this one's not going to help us anything. We don't know the angle H. We don't know the side H. Okay? So this is how we're going to set up this question. Sine of 51 over 7.8 is sine of 44 over side J. This is a ratio. All right, we can solve these always using cross multiplication. Okay, just like you did with trig back to grade 10. So we're going to go 7.8 times sine of 44 equals sine of 51 times j. And since we want j by itself, let's divide by sine of 51. Okay, so this would cancel, and you'd be left with j equals, and now you need to put this whole thing in the calculator. Quick little comment. Don't round off until the last step. So I don't want you to like typing in sine of 44 and then going something like this, 7.8, and then let's say sine of 44 is 1, let's say it's 0.8. I don't want you to write that. I want you to keep it in the calculator because it's going to have all these other decimals. I want the whole thing in the calculator. Okay? Alright, if I put that in my calculator, I get 6.97209, etc. And usually, when we're finding side lengths, we'll go to 1 decimal. So I'm going to write this as, 6 point, what? This actually is 7.0. Okay? Let's check the next one out. Here we're supposed to find angle N. Okay, so that means we need the ratio with angle N. So let's write sine N over side N. Okay, equals, let's go sine M over side M and sine P over side P. And let's fill in what we know. Okay, you don't know angle N or side N. You know M, the angle is 92 and the side is 11.8. And you don't know angle P, but I know side P. Okay, now in this case we're not going to use that one, which is odd because we are supposed to find angle N. But hopefully you can see that if I can find angle P, if I find this angle, then I'll have 2 of the angles and I'll be able to find the third one. Okay, so let's try and complete this question. Let's cross multiply. Sine 92 times 10 equals 11.8 times sine of P. So sine of P is going to be sine 92 times 10 divided by 11.8. Okay, let's put that in the calculator. Sine 92 times 10 divided by 11.8. And we get 0.8469. Don't take it off your calculator. Leave the whole display. Now, if you remember, how do you find an angle? Take the inverse, and I want this whole thing to go into here. So hopefully your calculator has the answer button. If not, you have to put the whole thing in. Alright, and this is 57.8, and usually with degrees, we round off to the whole degree. Now you guys should know this on your test. Alright, what did I do for degrees? Whole degree. What did I do for sides? 1 decimal. Okay, it's not going to say it on the test, you just need to know that. Alright, put a little star there, make sure you remember that. So this question is saying what's angle N? Well, we'll go 180, take away 92, take away the angle we just found, which is 48, and so angle N turns out to be 30 degrees. Alright. This one's a little different. It says solve the triangle. That means we're supposed to find all the missing parts. It also is different in that there's no picture. So don't stress about the picture. I'm just going to write it exactly like I see it. DEF, DE is 5, angle D is 80 degrees, doesn't have to be to scale. FE is 8, and that's all it gives us. Okay? So let's start with what we know. Sine of D over D, and let's use what else we have. Sine of F over F. Okay, so sine of 80 over 8 is sine of F over 5. Cross multiply. Sine 80 times 5 equals 8 times sine of F. So sine of F is sine of 80 times 5 divided by 8. Let's try that. Sine 80 times 5. Oops. Sine 80 times 5 divided by 8 equals. Okay, so you get 0.6155, etc. So sine of F. And so what is F? It's going to be the inverse sine of what's on your calculator. And F is 38 degrees. Okay, now if you remember, this question said solve the triangle. So I would like you to get into this habit. We asked to solve a triangle. I would like you to list all the parts. Okay, now D is 80 degrees. We just figured out F is 38 degrees. Okay, since F is 38, you now know what the third degree is. This is 180. Take away 80, take away 38. So this should be 62 degrees. Okay, it gives us D is 8. We know that F is 5. How do we find E? Can you use Pythagoras? No, because it's not a right triangle. So we're going to set up, excuse me, E over sine of E. And then let's use the ratio that we were originally given. We knew those two. Okay, so you get E over sine of 62 is 8 over sine of 80. Cross multiply. And then to get E by itself, you're going to divide by sine of 80. Let's put that all in the calculator. 8 times sine 62 equals, divided by sine of 80 equals. Alright, and so we get 7.2. Now before we accept that as our final answer, does it make sense? Well, if you look at this answer, which of these angles is the biggest? The biggest angle has the side that's the biggest across from it. Okay, the smallest angle has the smallest side. So that should make sense. If you think about it, if you have two angles here, one is small, one is big, what can you tell me about the sides opposite from those two angles? Small, big. Okay, so the bigger the angle, the bigger the side across from it. Alright, let's stop there for today's lesson. You can do page 478, numbers 3 and 4.